All right, so today is a little bit of review from grade 11, and we'll just sort of take our knowledge from grade 11 and sort of step a further bit down the line. You like that?
Did you have all this when you first started teaching?
No, I've accumulated them. No. Do you think teachers get better as they?
Yeah.
Yeah.
Definitely.
You get better at teaching?
It's either they get better or they just get bored and worse.
That's
Some teachers
true.
get better, some get worse.
Yeah, I'm gonna agree with that.
And where do I fit in, Riley?
You get better.
Thanks, man.
You're learning some of like old tips and tricks.
Yeah. I know that, like, I right away know what this is going to be about. I know the jokes to say. Like, I just, oh yeah, I've done this.
I've done this.
Jokes to say. That's like the second most important thing.
Yeah, that's weird. Eh?
Just teaching them in second.
And then the jokes. What are the jokes that are in this?
Wait, what is this? Yeah, okay, good. I gotta get jokes now.
I'm glad to be known for something. All right. As Megan has pointed out, we got a lot to cover. So as I was saying, we're going to sort of take what we know. I'm going to go back to grade 11 a little bit, review a little bit, and then sort of take that a little bit, step down the road. Tomorrow, we're going to look at, I think, friction on a ramp, which is a bit of an upgrade, bit of a challenge. So today, calculate the coefficient of friction, solve problems on flat and inclined surfaces of modern friction. That might be extra tomorrow. Oh, Dawson, you're all set up there, ready to go. We've just begun. Now, again, I would suggest you not write anything down. This is just sort of that getting you in the right mental state, sort of frame of mind, reminder where we're at, what we know about friction. Yes? Sure. Where are you taking it? Mr. Who? Okay. Just one, or is there going to be like lots of people? Okay. I'm just letting you take it because I like it. You understand that, eh? Okay. Alright, so friction is a force that resists motion. It involves objects that are in contact with each other. There has to be contact for there to be friction. Right? Some causes of friction that we've discussed in grade 11, an object deforms the surface and vice versa. So the book, the hole punch is actually creating a little hole, a little hollow there. And so you actually have to go up a ramp as you're going along. That's one idea. They don't really understand a lot about friction. It's kind of, that on that molecular level, it's more than we need to know. Put it that way. Okay? Do you guys remember the difference between starting friction and sliding friction? No? Starting friction is the maximum frictional force between stationary objects. So friction is the most when it's actually at rest. You don't know, you don't have this. Actually, what I should say is all of these notes come from this reading. Okay, so I pulled them out of here. Christina, are you staying with us? Oh, okay. They're the worst, right? Yeah. I believe you. I do believe you. Okay? Starting friction is sometimes known as static friction, and sliding friction is sometimes known as kinetic friction. And you can have different... Do you remember what this coefficient of friction is? What's the letter we use? Yeah, that mu thing, right? It's the Greek letter U. Well, it's actually Greek letter M, but it looks like a U with a tail on the front. Okay? And static friction is sometimes known as mu S, and kinetic friction would be mu K. With us, term? Okay. It's in that reading if you want. None of this is stuff that you have to look up. It's just, I'm refreshing your memory. Okay, some properties of friction. Friction always acts parallel to the surface as they're in contact and in the direction opposite from the motion or the net force tending to produce such motion. In other words, if I push on the hole punch and it's sliding, well then the friction is opposite to motion, right?
Yeah.
If I'm very weak and I can't muster up enough, which way is friction? It's still opposite. It's opposite to the force, to the motion that might occur, right?
Just like
what we're going to do, but I've got a bunch of junk in there. Yeah. You're going to do that there. Okay, the second one is friction depends on the nature of the materials in contact and how smooth they are. Obviously, rubber, things that are rough, right, have a higher frictional coefficient. I often, in the spring, get the RCMP. Come on, have you guys ever seen that? I didn't do it last year. I was away 4 days last year for grade 12, and I didn't feel like I could experiment it. So I quite often get the RCMP accident reconstructionist. We go out to the street, and he fires up the car, the cruiser, hammers on the brakes, right, makes the skid mark, and then we measure it, and we determine the frictional coefficient, how fast the cop car is going.
Let's do it.
It is pretty cool.
Let's do it.
Why don't we just
For
use
last year.
Fred stuff?
Pardon me? Well, no. I have to go through the town, I gotta get the roadblock off with all the safety stuff, the paperwork, and
We're
all.
not doing it this year?
I didn't say that. I usually do it in the spring. I usually do it right around the May long weekend.
We can do it our way. We can go summertime.
Because it's not the May long weekend.
Right now.
Actually, the RCMP guy that I used to work with, he's moved away, and so I gotta find a new guy.
Yeah, we'll
That new
get
person.
truck walk over.
Greg gets pulled over and pull up.
I'll get my car and do it.
I was just a business officer.
Good luck with that. Don't leave my name out of it, Brett.
Okay, I will, but I'm still gonna use those excuses.
Sliding friction is less than or equal to starting friction. Friction is practically independent of the area of contact. And starting or sliding friction is directly proportional to the force pressing the two surfaces together. Now, this is important. Okay? If, let's say I've got the book here on the table, and the friction is some value, right? As I push it, the friction is some value. But if I increase the mass, if I put this big heavy book on top, how much is the friction? More, because, how come?
The mass.
Well, it's not so much the mass. I mean, the mass is the indirect cause of it, but it's because there's more weight force, right? And so the weight force crushing the two surfaces together. The weight force down and the normal force up are greater, right? Do you remember this formula? I think it's next. There it is there. Remember that formula? So the coefficient of sliding friction is the ratio of the force of sliding friction to the normal force. So I'm just going to make this a smidge bigger. So if, now, when I did the binder on top of the book, did I change the mu value?
No.
I didn't, right? What did I change?
The normal
I
force.
changed the normal force, okay? So let's just say the mu value, and do you remember what mu values usually are round? Like what are they sort of equal to?
Decimal.
Under 1.
Usually less than 1, right? So let's say that the mu value is 0.2. Josh, you look like you're playing on your phone. I'm not accusing you of that, I'm just saying that's what you look like. So, you look like you're just sitting there chilling. If the weight force is increased, well then that's going to increase the
Normal force.
normal force. Now, to make this ratio the same, if the 0.2 is going to be the same, what has to happen to the friction force on top for it to be 0.2? It has to be made equally as big. And what is that FF? The force of friction. So again, it's not because the coefficient of friction changes. The friction force changes because the normal force gets changed. Now, what if I throw this into the mix?
Uh-oh.
Remember what happened to the normal force yesterday? It was at an angle, right?
Yeah.
And in fact, the steeper it goes,
Oh, you
no,
hold that in.
friction force is up the ramp, right?
And then the weight force would be.
The weight force is straight down, but the normal force is dependent upon the angle. And so,
That's greater than.
that's right. Now, how come yesterday it would have been sliding?
Because the weight force is not.
Normal force.
More weight, exactly. So I increase the normal. So I have to increase the angle,
It
right?
would slide easier for a second.
We're all good. You guys are making good.
Yeah, I thought it was slightly easier for the second.
Well, we have an example.
Oh yeah?
Yeah.
Well, you do it.
You should have this example in that packet, right? How many examples are there, Brett? 3? Okay. So my goal today is to get through those 3. So you have it right there, so it shouldn't take us too long because you don't have to write it out. So we got an object, mass 10 kilograms, force of 100 newtons applied to it, the coefficient of friction between the two surfaces is 0.25. determine the object acceleration. Now this is really, to be honest, this is more of a grade 11 kind of degree of difficulty. A harder grade 11 version, right? But for you guys, it should be somewhat reviewish. Okay, so should we draw a picture? Feels like we should, right?
Yes.
So 10 kilos. Now it doesn't say what angle this 100 newtons is. It doesn't say left or right, but we usually live in that left to right world. So we're going to say that my FA is 100, right?
Yes.
Coefficient is 0.25. Determine the object acceleration. Do I need to include the weight force and the normal force? Technically you should, but do they have any effect on this question? It's just a sideways thing, so it doesn't really matter. But we know that the FF is that way, right?
Does it make a difference where you draw your applied force?
You mean like there, or can I do it? There?
Yeah.
No, it doesn't. Some books like to put it there. Yeah, just a convention. Okay, so what's my first step? Determine the object acceleration. To get the acceleration, I'm going to need the net force, right? EJ, I'm going to need the net force, right? I got the mass. How do I get the net force? It's the sum of all the forces. So the net force is going to be the FA plus the FF, but I don't have the FF, so how do I find the FF? Going to use the mu. Mu equals FF over Fn. Do I have Fn? I don't, so I'm going to go back one more step. Find that one first, right? There you go. Those are the steps.
Last time.
It's a few steps.
So we did need friction or
No, there's no deriving.
driving.
You know what they said at the calculus professors convention after the big party? Don't drink and drive.
Oh my God. God.
Drive.
That one wasn't planned for this lesson, but it just came up. Ty's just giving me the "Are you serious?" look.
The other one was better.
Yeah.
No, I like this one.
Should make
Drive.
Physics teacher jokes.
Just be a comedian.
Stuff that it says.
Be a comedian, go to Montreal, and just like perform on stage.
Yeah.
People will laugh because it's really cheap.
You
Oh,
like teaching a lesson, you'll teach a lesson.
Oh, Mr. Bernard Tyus just come stand up to me.
I've always thought I'd want to do that.
I mean, your students.
And just heckle the out of me, right?
Oh, yeah.
Totally. And I just send them all to the office. Maybe that would be my stand-up comedy, my character would be angry science teacher, right? When the hecklers come, just send them to the office. That sounds like a bad idea. Really bad idea. Okay, so if the weight force is 98 newtons, therefore the normal force is also 98 newtons, right?
Yes.
Do I need to write that, do you think?
I think so.
Maybe in an example we will, okay? In an example. It's kind of, at this point, it's kind of self-explanatory. Okay, so the mu value is 0.25 friction force. The normal force is that 98. So I got to take that and multiply by 0.25. 98 times quarter. 24.5. Now what? Say again? I gotta find F net, don't I first? 24.5. Now, notice the friction force doesn't get to be made negative. Well, because it doesn't come out of here, right? Like you have to assign it that direction. You have to realize, oh, it's going to be opposite. It's going to have to be a negative. Okay, it's going to be a manual. You're going to have to manually change it to negative. No. I just mean you have to manually change it to negative. It's not automatic. So of course that's going to be 75.5, right? And now F net is equal to MA. Divide by 10. 7.55 meters per second squared. Would you now agree that that's sort of a top level grade 11 kind of question?
Yeah.
Like there's nothing new there really, right? Yeah.
You already did a question like this on that paper that we did.
Probably. Okay, now. Now we're getting into the grade 12.
Oh, shoot.
Object has a mass of 10 kilos. Placed on a ramp with an angle of 35 degrees. The coefficient of friction is 0.15. Determine the object acceleration down there. So it's literally exactly the same question as the previous one. It's just on a ramp, right? Do you feel like we should draw a picture? Yeah, I think so.
Well, I was drawing that.
See what I see. That wasn't even me. Yes, it was.
Now. So I got FW straight down. I'm going to this convention today because it seemed to be what I was doing in the solutions yesterday. So I'm calling that F perpendicular, which is really the component of gravity that is perpendicular to the ramp. We said it was Fn, right? I was talking to Megan about this yesterday. Really, it's because the Fn is opposite. The Fn is up, right?
Give that a better, like, what is it? Can we give it an F?
It's an upside
You
down.
can call it Fn if you want. Yeah. I mean, it's technically it's not. It's just numerically equal to.
Okay, but if we know that,
Yes, I'm good with that. Perpendicular. That's the perpendicular sign. It's upside down T. Okay, now there's one perpendicular to the plane. It's 90 degrees to the ramp. Okay? And the Fn, which is up, is numerically equal to, but in the opposite direction. Now there's one more force here. Friction. Which direction is friction? Up the ramp. Why? Because it's going down, because it's sliding down, right? What if there's a rope or something that's pulling you up the ramp?
It'd be the opposite way.
Friction is down, right? Is the FD always down the ramp?
No.
Yes, it is. FD, it means down.
Darn it.
Yeah. You're a little bit too quick on the buzzer there, Jeopardy boy.
So the only reason we know that there's an FF is because it doesn't say this is a friction.
That's true. Well, it gives us a coefficient of friction, so, right? Yeah. Yeah. Otherwise, object acceleration is just g sine theta, right? Okay, so our F net is really, just write this on the side as a sort of a thought. Our F net is really the FD plus the FF, right? Our net force is this FD, which is here, right, minus that FF.
but we don't know yet.
We don't know any of this. All we know is the mass and the 35 degrees and the coefficient of friction. Okay, so what were the two formulas that we came up with yesterday? Do you remember?
I got it written down right here.
I just found something.
We're going to need them, right?
FD equals mg,
mg sine theta, so let's do those.
And then FM mg.
mg sine theta, so that's going to be 10 times 9.8 times the sine of 35.
But since there's friction, we can't use the easy one. Right?
No, we can use that.
Oh. Why?
We have to use it. 56.2. That just tells, that is actually true whether there's friction or not. That's just how much gravity is pulling it down the ramp. Brett, you should watch. Your mom's busy. She can't talk right now. Who?
Aha,
On your phone.
aha.
He's talking to me.
You can wait.
You're right. You're right. Okay, now my Fn is mg cos theta. Get that out of the way. So that's going to be, oops, 10 times 9.8 times cos 35.
Make
80.3? Oh yeah. Guaranteed, any rap question, you're going to need both of those. Is it worthwhile finding the FW?
Yes.
No.
Not really, because you're going to have to go multiply by the angle anyway. So you can if you want, but there really probably won't be a mark for it.
Okay.
Okay, now determine the object acceleration on the map. Now, one more step from yesterday, right? So I need to know what Fnet is. I got my Fd, but I do not know my Ff. So I'm going to have to do my Ff. So that's going to be mu equals Ff over Fn. And now my new Fn, here's the mistake that kids always make, is they forget about this, and they just put the Fw in there. They go m times g. That's the mistake that most kids make. Okay, so we're going to go 0.15. So for friction force, Fn is 80.3.
Make
12 newtons of friction. Now, what are the two ways that I could increase the friction there?
More weight.
more weight,
More gravity.
mass.
Well, you can't change gravity, but you're right. More mass
Less angle.
would make that bigger, right?
Less angle.
Less angle.
More gravity.
Yeah, right. Or greater coefficient, I guess, right? Regardless, the 12 newtons is the friction force. Fnet is equal to Fd plus Ff, right? Fd is 56.2, and again, manually change that friction force to negative. $44.2, I get. Yeah, right? Last step, find the acceleration.
See, this goes way faster
What do you mean?
when we're actually in by ourselves.
How many steps there? 1, 2, 3,
6.
4, 5.
Both of us too early, right?
Okay, last example. How about you guys take a moment to draw the picture. Try to draw the picture. I gotta do it before 3 o'clock. Try to draw the picture.
On a level.
Okay, whether you're done or not, I don't care because I'm gonna go on. I'm gonna get done.
You didn't even draw the picture.
Now, there's a couple of key words here, Danielle. There's a couple of key words here you should highlight or underline, AJ. First of all, constant speed. If you ever see that, make a note, because constant speed is code for zero acceleration, which means the net force is 0. The net force is 0. Right? Constant speed. Net force is 0. Makes an angle of 30 degrees with the floor is shown. If the force on the rope is 260, what's the horizontal component? I got an FH there. Change that to FAX. What's the normal force? So we're trying to find out what the coefficient of sliding friction is. Okay, so I'm going to do it up here in the corner. FA.
Right?
This is FAX and this is FAY, right?
Yes.
And the friction force is going to be opposite. And now, does the weight force, the normal force come into play here?
Hmm.
And actually it does. Even though there's no motion up and down, because there's a portion of this force that's vertical, Danielle, that you're going to have these forces in here.
Yes. See, I was
Okay? Because there's a little twist here.
So why
A rather large twist, actually.
why do you put your FN if your FA is your FN?
My FA is not my
Your
FN.
FAY.
It is not my FN. The I'm glad you spotted that. The FW and the FN and the FAY are all vertical. They have to add up to 0. So because there's that little upward Y value, what does it do to the FN? Makes it smaller.
Oh.
Okay? You can remember that here. Okay, so let me show you how we do that here. So what is the horizontal component? That one's easy. Let's do that. So I've got FAX is going to be FA cos theta, which is 260 cos 30, right?
Yes, yes.
260 times 30.
Excuse me.
It's 225. Newtons sideways. Do you feel like the FAY is important?
Yes.
But you're not quite sure why? You don't think it is
You
important?
asked it, and I think
It's important.
Well, it's important.
Okay, so this is a little bit of preview of something that we're coming up to next week, but would you agree that the FW plus the FN plus the FAY is equal to 0?
yes.
Why, yes? It's not because it's a constant speed. It's not moving, it's not accelerating up and down, right? Those are all 3 Y forces, right?
Yes.
So there is no movement, there's no acceleration up or down, so the sum of all the Y's has to be big times 0.
So FAY.
So FAY is important, isn't it, right? So I'm going to just drag this, you probably wrote it there, I
Well, then-
apologize.
Wouldn't FAY be 0 then?
No, FAY is going to be actually equal to FA sine theta, isn't it? Right, that's going to be 260 sine 30, right?
What happens if the force is like, when you're pulling a sled, so you pull it too hard, and then like actually.
And then that's because the net your FAY is actually bigger than FW, bigger than the force of gravity.
Okay. Would there be a question like that?
I don't recall one coming up. So 260 times sine 30 is 130. Now, we got to be careful with signs here, right? I don't mean sign cosine, I mean like positive and negative. What direction is that, the FAY? Up, so we're going to leave it positive, right? Okay, so now I got to take this and I got to plug it in down here. Do I have my FW? I don't have that yet, do it. So you're going to need that as well. FW equals mg, so that's going to be 40 times 9.8. $392. That is down. That is negative. Thank you, Brett. Correct. So now, if you'll pardon the pun, normally the FN
Hey.
is equal to 392, right? But it's not because we're doing some of that upward work. We're doing some of that FAY is lifting it up, right? So the way I'm teaching it now is I'm going to plug these 3 things over here. So the FW is minus 392. We're solving for FN, and my FAY is plus 130. And we might have gotten into this in grade 11 a little bit, I can't remember.
Very slightly.
I don't
Yeah.
remember.
Explain it like this.
Okay, maybe I did, and it just was over your head at that point. Probably, yeah. You're going to see it more now. Okay, so I'm going to leave the FN on the left and take the numbers to the right. So that's going to give me 392 minus 130. Is it always going to be subtract here?
No. Yes.
All depends.
I'll let you think about that for a second while I do the arithmetic.
It's not
Yeah, it will
subtract.
always be subtract.
And that means you're pulling the sled up.
They're always going to be opposite?
Yeah,
Think about it, Ty.
no, what if it's on an angle?
If I'm pulling, then the FAY is up and it's opposite, right? But what if I'm like pushing a lawnmower?
Oh,
If
God.
I'm pushing down, if I'm pushing down, then it's actually going to increase the normal
What if
force,
the
right?
gravity's like not there anymore? And what if the Earth is pushing if the Earth is pushing you away?
Well, not you realize that.
Blah, 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 blah. Oh, uh-oh. Okay. I know my FN now, right?
Yep.
Because the last step is to find the coefficient of friction. I know my FN, it's that 262, but I don't know the friction force.
Oh, darn it.
There she goes.
Holy crap.
Well done. Why is the FF equal to the FAX?
Because that's
Constant speed. I mentioned that right at the start. Because it's a constant speed, that means our FAX and our FF are
The same.
the same. I'll get that phone. Don't worry, I'll get that phone right away. So this is going to be
So mu would be 0.
225,
And
right?
mu would be 1.
Hello? She is. Okay, she'll be right there. Okay.
Wait. Is that
So you just do that division there, right?
Oh, never mind.
225 divided by 262. I don't know. Do you want to help me out?
0.85.
0.85?
Yeah.
Is that a pretty rough surface?
Yeah.
Yeah. Yes, that's pretty rough. Like when we do the RCMP out there, rubber on a dry road is like 0.3, I think, something like that.
That's not rough, sir.
So that's pretty rough.
We're going through some sand.
Good question. Danielle's asking, is there any units? There is not, because the friction force is measured in newtons, and the normal force is also measured in newtons, and there are no units for mu.
I remember that.
You remember that? No units for mu. Okay. If I'm not mistaken, that is the end. We've got 25 minutes, so that's nice. So there's a bunch of questions there. There's a QR code, but there's no actual link. But there are answers on the back. Okay? So tomorrow's Thursday.
Friction questions?
I will likely do the old usual. I'll do teaching. Anyone away tomorrow? You're away tomorrow? Anyone away Friday?
I work.
Okay. I will likely do the same thing as usual, the sort of lesson on Thursday, and then give you Friday to do some work. Yeah, well, it's going to be very similar to this. I think it's just more textbook friction questions.